Now, let us talk about matrix multiplication. Without in any way trying to cram the rules which we are going to talk about, but just by simply following the processes of solving matrix multiplication in the examples to come. Okay, so for it to be possible to multiply two matrices, the first matrix must have the same number of columns as the second matrix has rows. Secondly, the product will have the same number of rows as the first matrix and the same number of columns as the second matrix. Let us do a quick check with these three samples of the statements just made. So the first matrix, which we say must have the same number of columns as the second matrix has rows. Let's check how many the first matrix has how many columns. 1, 2 columns, and the second matrix has the same number of rows. Good. Then sample B, the first matrix has how many columns? 1, 2, 3, and the second matrix has how many number of rows? 1, 2, 3. Good. The third sample, the first matrix has how many number of columns? 1, 2, and the second matrix has how many number of rows? 1, 2. Good. Then for the second statement, it says that the product should have the same number of rows as the first matrix and the same number of columns as the second matrix. Let's check with the first sample. The product has how many rows? 1, 2. Good. And the first matrix has how many number of rows? 1, 2. Good. The second matrix, how many number of columns? 1, 2. Right. Then the second sample, the product has how many number of rows? 1, 2, 3. The first matrix has how many number of rows? 1, 2, 3. Good. Then the second matrix has how many number of columns? 1. Good. You can see that. Then for the third sample, the product has how many number of rows? 1, 2, 3. And the first matrix has how many number of rows? 1, 2, 3. Then the second matrix has how many number of columns? 1, 2. Has how many number of columns? 1, 2. Same as the product, which has 2 columns. Good. You don't need in any way to cram these rules, because in the process of trying to solve the matrix multiplication, you will see clearly that there is no need for you to worry about these rules. Just solve the matrix multiplication right and you will have the right answer. Okay? Good. Let us now take a look at this example of matrix multiplication. With this matrix of 2, 1, 1, 2 to multiply matrix 3, 2, 1, 3. So what you basically need to understand is that the rule of the first matrix will multiply the column of the second matrix in this format. Let me just draw this. Okay, so the element 2 will multiply the element 3, then you add the product to the product of the element 1 multiplying element 2, that is 2 times 3 plus 1 times 2. That is what is going to occupy the element of the resulting matrix. Okay, so you still take the same row to the next column. You do the same thing with the next column. Okay, so we have 2 times 1, 2 times 1 plus 1 times 3, 1 times 3. Okay, then you come down to the next row of the first matrix, which is 1 and 2. Then you do the same thing, use it to multiply the first column. Okay, so 1 times 3, so you have 1 times 3 plus 2 times 2 plus 2 times 2. Then you do the same with the second column of the second matrix. Okay, so 1 times 1 plus 2 times 3. Okay, so now let's work this out. 2 times 3 is 6 plus 1 times 2, which is 2. So 6 plus 2, that will give us 8. Then next, 2 times 1 is 2 plus 1 times 3 is 3. 2 plus 3, that will give us 5. 1 times 3 is 3 plus 2 times 2, which is 4. So 3 plus 4 will give us 7. 1 times 1 is 1 plus 2 times 3 is 6. So 1 plus 6 is 7. So this is the resulting matrix. So if you look at this, we've indirectly gone through the rules that says the number of rows should also be the number of column of the second matrix, and that the number of rows of the first matrix should also be the number of rows of the product. Okay, and also that the second matrix should also have the same number of columns. Okay, so indirectly, once you follow these steps, there's no need for you to cram anything. So the basic thing is, you take the row, use it to multiply the column, then the same row, use it to multiply the second column. So no matter the number of columns, you take that row, use it to multiply the columns. Okay, now let us take a look at another example. Now we have a 3 by 3 matrix to multiply a 3 by 1 matrix. So the primary thing is the number of columns of the first matrix must tally with the number of rows of the second matrix. You don't need to really bother yourself about all this. It's just for a check, because most of the questions you'll be given in exams, they will actually give you the right columns and rows and all that. Okay, so the next thing is to take the element of the first row and use it to multiply the column. We just have one single column here, so good. So now we have 3 times 1, 3 times 1, then plus 1 times 1, plus 1 times 1, then lastly 1 plus 1 times 2 plus 1 times 2. Okay, then you go to the next row, 2 times 1, right, 2 times 1 plus 3 times 1 plus 3 times 1 plus 1 times 1. Okay, plus 1 times, no, plus 1 times 2. Okay, then you come to the last row, 0 times 1, write 0 times 1, then plus 1 times 1 plus 1 times 1. Then the last element, 1 times 2 plus 1 times 2. So now let us work this out. 3 times 1 is 3 plus 1 times 1 is 1. So 3 plus 1, then plus 1 times 2, that is 2. So we add everything up. 3 plus 1 plus 2, that gives us 6. 2 times 1 is 2. 3 times 1 is 3. 1 times 2 is 2. So 2 plus 3 plus 2 gives us 7. Then 0 times 1, 0. 1 times 1, 1. 1 times 2, 2. So we have 0 plus 1 plus 2. That gives us 3. So this is the resulting matrix. So now let us take a look at this question. We have a 3 by 2 matrix to multiply by a 2 by 2 matrix. Okay, so as usual, we take the row of the first matrix, we use to multiply the columns of the second matrix. So we take the first row now. 0 times 2, 0 times 2 plus 1 times 1 plus 1 times 1. Then we go to the second column. 0 times 1, 0 times 1 plus 1 times 2 plus 1 times 2. Then we come to the second row. 1 times 2, 1 times 2 plus 0 times 1 plus 0 times 1. The second column, 1 times 1, 1 times 1 plus 0 times 2 plus 0 times 2. Then the last row, 0 times 2, 0 times 2. 1 times 1 plus 1 times 1. Then lastly, 0 times 1, 0 times 1 plus 1 times 2 plus 1 times 2. So now let us work this out. 0 times 2 is 0, 1 times 1 is 1, 0 times 1 is 0, 1 times 2 is 2, 1 times 2 is 2, 0 times 1 is 0, 1 times 1 is 1, 0 times 2 is 0, 0 times 2 is 0, 1 times 1 is 1, 0 times 1 is 0, 1 times 2 is 2. So let's add everything up. 0 plus 1, we have 1. 0 plus 2, we have 2. 2 plus 0, we have 2. 1 plus 0, we have 1. 0 plus 1, we have 1. 0 plus 2, we have 2. So this is the final product. Good.